So finishing off this little set of lectures about the outer solar system, as I said, we got Voyager 1 and 2 and Pioneer 10 and 11, leaving the solar system as is New Horizons. So they are on the way out, having visited, all of them have actually been to Jupiter. And then Voyagers 1 and 2, and then Pioneer 11 were slingshot on to Saturn. The Cassini spacecraft was another one designed to study just Saturn and its moons, and it had to go by Jupiter on the way in order for Jupiter to slingshot it onto Saturn. And so it went by Jupiter too as a way station, and went by on the way to Saturn. And so it saw Jupiter and Saturn. Pioneer 10 just saw Jupiter, and so then it was slingshot past Jupiter out of the solar system. Ulysses spacecraft was trying to study the north and south pole of the sun, but we didn't have the rockets to actually do that. We didn't have enough rocket energy. So we actually sent them to Jupiter and let Jupiter's gravity toss them into orbits perpendicular to the orbit to the rest of the planets in the solar system. And so that allowed it to move perpendicular to the rest of the solar system and actually see the north and south pole of the sun. But along the way, it got to study the environment around Jupiter. Galileo was a spacecraft sent to Jupiter, as was the Juno spacecraft. Galileo quite some time ago, and then Juno much more recently. Juno is still operational, orbiting Jupiter. And so right now, Juno is orbiting Jupiter, sending back data. New Horizons is probably going to visit another Kuiper Belt object. Voyagers 1 and 2 are still operational, leaving the solar system, but just barely, and they probably won't last much longer. The rest of these no longer are in operation. Ulysses, like I said, slingshot past the sun, past Jupiter to toss it into an orbit where it allowed the sun studies. This was done quite some time ago, but it was the very first views of the north and south poles of the sun, and was the first look at Jupiter since the heyday, what we call the golden age of space exploration. Golden age of space exploration was when we were in the 1960s and 70s, sending spacecraft everywhere we could send spacecraft. We had more money, government money, funding to do this sort of thing at that time, and so they were sending things all over the place. By the time we got to the 1990s, this was sometimes called the Silver Age of space exploration. And so instead of sending a whole bunch of spacecraft all over the place, it was a handful of spacecraft, a few, but each one of them was much bigger and more extensive and more expensive. And so that was the idea they had at that time. Ulysses, and then Galileo and Cassini. They're part of these bigger and better plan. And so the bigger and better plan, Galileo was launched in 1989 to Jupiter, and Cassini was launched in 1997 and went to past Jupiter all the way out towards Saturn. All these things, because they're so far from the sun, use RTGs to power themselves. And so the bigger, better model actually gave way later in the 2000s to smaller, faster, cheaper idea. And so that was the new idea they had, was do away with sending these one, super massively expensive sort of things and send several smaller, faster, cheaper things. And so that we've switched back to that model here. So we now, in recent years, have had kind of a resurgence of what was the golden age of space exploration, in which we are now building far more spacecraft and launching them. The technology has gotten better for launching, and it's gotten a whole lot cheaper to build the spacecraft and launch them. We now have such a robust commercial satellite industry that the ability to build spacecraft has become very, very well studied and we're very proficient at it. Juno mission, most recent one, arrived in Jupiter in 2016. Took 5 years to get there, but it went into orbit. Juno is interesting because it is the first spacecraft out that far to use solar panels, and it has this trio of really monster-sized solar panels. So the trick was to build solar panels that are vastly more energy efficient, and so that allowed it to operate out there and make them big enough so you can unfold them. You can't have fixed solar panels that far out because the spacecraft's too big to launch. So make them in such a way that they reliably unfold. They took a little bit different way of getting there too. It used a smaller rocket to launch, and so when it launched the rocket, it actually launched it not directly to Jupiter, but kind of the way that Galileo launched. Galileo also did not go directly to Jupiter. Galileo went out to the outer part and then came back and slingshot past Earth again, and then Earth tossed it out further. So Galileo did that, and Juno did the same thing. Both of them launched around here and let Earth slingshot it further out to get to Jupiter. The missions are not really over yet because the spacecraft are still going. Remember, we have 5 spacecraft leaving the solar system. 4 of them have actually reached essentially interstellar space, and those are the 2 Pioneers and the 2 Voyagers. Now, the 2 Pioneers no longer operate, and they quit working long before they reached this point. And so we don't really know what they found when they got there. But the Voyagers are. What happens is, and we mentioned this a little bit when we talked about space weather and so forth, that you have solar particles going out from the sun. Now, as solar particles go out from the sun, the solar wind, as it goes out, it turns out there's actually particles in interstellar space, what we call the galactic wind. And so we have interstellar medium out here. And so what happens is that the solar particles, the solar wind comes out, as it starts slowing down, it's bunching up out here. And where it's bunching up, we have all these particles bunching up. So as a spacecraft goes through there, you notice an increase of particles and radiation. We call that the termination shock. And the edge of the sun's domain we call the heliopause. So this is where, once you reach past the heliopause, you're in interstellar space. Prior to that, the sun dominates. Now, as these particles from space are moving through, then as they get close, they get pushed around, so they're bunching up outside. And we have what's called the bow shock. So we have 2 big regions of radiation out here, the termination shock and the bow shock. Okay. And then the heliopause is the boundary. Both Voyagers reached this termination shock quite a few years ago, and so we were just waiting for them to reach the heliopause. And they have now both crossed the heliopause, and one of them, Voyager 1, the fastest one leaving, is now crossing the bow shock in true interstellar space. And so we're now getting our very first view of the interstellar space. Now, the problem here is twofold. They are very, very far away. The signals are very, very weak. Their RTGs are wearing down, so they give you less power to send signals. And Congress wants to cut the budget to the facilities that monitor them. So they launched Earth in the mid-1970s. Here we are, 2020, and they're just reaching interstellar space to give our first up-close view, and Congress wants to cut the budget and say, we want to shut them off now because they're so far away not doing much. Well, they are just now starting to reach interstellar space and have a resurgence in their mission here. So hopefully we're not going to lose track of them anytime soon. We did actually did take the Deep Space Networks offline for a little bit to update them, and as they come back online, we did send a signal out to the Voyagers and got a signal back. So they are still operational. They are so far away now, it takes hours for radio signals to get there and then hours for radio signals to get back. and they are just now reaching the edge of interstellar space. They are not headed towards the nearest star, but if they were, it would take tens of thousands of years to get there. This gives you an idea as to how big space is. As they approach the beginnings of interstellar space and figuring out things, we're realizing the bow shock is not quite as prominent as we expected it to be. This is something that was a little bit of a surprise. There's several things here about they're finding about Earth's or the sun's heliosphere that's a little bit of a surprise to us. We know it's not spherical, that they were expecting it not to be spherical. It turns out it's probably being a little more spherical than expected, which is also a surprise, and so we're not entirely sure what's going on out here. But this is actually an area of study that is currently underway to figure out, why are things the way they are out there.